An electron. It's not a particle, but it's not a wave either. We observed this through one of the most popular experiments in quantum physics, the double-slit experiment. Let me try to explain this seemingly complex experiment and its results in the simplest way possible, using examples. First, let's start with examples from the world you know. Imagine you have some marbles. In front of you is a board with a slit in the middle, and behind it is a kind of sheet where these marbles will hit. Let's throw the marbles one by one through this hole. Some will hit the board and won't get through, while others will pass through and leave a kind of pattern on the sheet opposite the hole, like a single line. If we increase the number of slits on the board to 2, we will see 2 separate line patterns on the opposite sheet. This is what makes sense and what should happen. A particle behaves this way. Now let's do the same experiment with a puddle of water, and let's see how the waves behave. The waves we create in the puddle passing through a board with a single slit form a single wave and create a single line pattern at the point where the wave is strongest on the opposite sheet, just like the marbles we sent through a single slit. Again, there's nothing unexpected here. But when we open a second slit, a single wave passing through 2 slits creates 2 different waves, and these 2 waves intersect, creating a kind of multiple line pattern on the opposite sheet, a result of intersecting waves creating different wavelengths. There's nothing unexpected here either. It's a situation we can normally observe. Waves behave like this. But let's press the quantum physics button, step into the quantum world, and repeat this experiment there. Now, we've said that light is carried in packets called photons and is essentially a particle. So if we think of photons as marbles and send them from a photon gun to a single slit, the result of this experiment is great. A predictable result comes out. On the opposite sheet, just like with the marbles, a single pattern emerges. Photons also behave like particles, just like marbles, okay? No problem. Now let's open the second slit, just out of curiosity, as we've actually proven that it's a particle. But things go off the rails here. The brain-burning ceremony begins at this point, so hold on tight. When we shoot photons we know and have proven to be particles at the board with 2 slits, we expect to see 2 separate line patterns on the opposite sheet, just like with the marbles. That's the result. The photons we shoot one by one create a pattern on the opposite side that is exactly like the pattern created by a water wave, a multiple line pattern, also known as an interference or intersection pattern. Wait a minute, how? We're reducing the number. Are we saying that the photons created a light wave because we sent too many of them? We send photons at a frequency of 1 photon per second. After hours, the result is the same. How? It's a particle, but it's a photon. How does it create a wave pattern? We threw a marble. How did the marble behave like water? Welcome to the quantum world. Is it over? Not yet. It's very strange. Hold on tight. Now, maybe the photon is behaving strangely. After all, there's light involved. Scientists say that light may also behave strangely. They decide to try this again with electrons. With a particle that is more similar to the marbles we know, they make an electron gun. They send electrons through a single slit. Great. A single line, like marbles. Then they open the second slit as well. So what happens? 2 lines? No, a multiple line pattern. Electrons also behave like waves when a double slit is open. Wow. Yes, wow. Something is strange. This is very strange. But wait, it's not over. Logically, scientists want to solve this problem. They place a detector, a sensor, in front of the slits, a device that makes a sound every time an electron passes, and they repeat the test. This is where the strangest thing in the world really happens. After placing the sensor, they start shooting electrons through the double slit. The test is over. When they check the opposite sheet, what do you think they see? 2 lines, as it should be. The electrons sent piece by piece create 2 lines on the sheet, like marbles. They turn off the sensor again. They repeat the test. Result? Multiple lines. Wave pattern. How? Yes, when you place an observer, a device, electrons behave as they should, as if they know they are being watched, as if they have consciousness, like an individual who behaves normally when we look and does very strange things when we don't look, like a child. So what's the explanation? There isn't one yet.